Morning. Welcome to Algebra 2. We're looking at 9.4a. The quiz covers 9.2 and 9.3. We are looking at restrictions on assignment 9.4a, and the factored form reveals the values of x that are restricted. Now it seems kind of mean to say no to some of these values of x. The upside is that we won't have that embarrassing situation where we're dividing by 0. So factor this into x plus 5 and x plus 1 divided by x plus 5 times x minus 5. The factored form reveals that we cannot let x equal negative 5. Are there any other restricted values of x in this rational function? X cannot equal negative 5, for otherwise this factor would be a 0, and we'd have division by 0. Is that it, or are there any other restricted values of x? So what do you think, Owen?
No idea.
Well, what you do is the restrictions are basically values of x that would cause the denominator to equal 0. Now, negative 5 is one of the values that will cause the denominator to equal 0. Can you think of any others?
Positive.
Sure enough, x cannot equal positive 5 is another restriction, because then this factor would equal 0, we'd have division by 0. We don't have to worry about the numerator. It's okay to have, it's when the 0 is undefined, found under the fraction bar, that we have trouble. Any questions on how to factor the expression below fully? Cancel any factors. So to follow the directions here, I need to go through and cancel the like factors. So it looks as though the answer to problem 1 is what's left post cancellation. The only thing that's left over is the x plus 1 upstairs, x minus 5 downstairs. The restrictions are in the box. Any questions on problem 1? Simplify and list restrictions. Would you please attempt problem 2 on your own? Try to simplify the expression by factoring and canceling. List any restrictions in the box. Thomas.
Can you just cancel the x's on number 1 together?
So like these x's cancel out to get a final answer of 1 over negative 5? No. And here's an example of why you cannot do that.
Does he mean the x squared at the beginning of the problem?
Oh, well, let's find out. Thomas, are you talking about the x squared at the beginning of the problem?
I meant the x plus 1.
You meant what I was talking about?
Yeah.
Okay. So, it's not every day that I correctly interpret a student question. Today's my day. Just pulling up the attendance here, but just to make my argument on this, suppose x was equal to 7. Okay, let's take 7 plus 1 over 7 minus 5. Now, it is undeniably true that 7 plus 1 is 8, and that 7 minus 5 is 2. So we know that whatever we do to this, the answer is got to be 4. Now, let's take your idea and explore it a little bit. Suppose I cancel the 7s. If I cancel the 7s, then we end up with 1 over negative 5, which is negative 1/5. So that leaves us with the question, is negative 1/5 equal in value to 4? Something must have gone wrong here. They're not equal in value. I'd probably rather have $4 million than be in debt on $200,000. Here's the problem. Once you cancel those 7s, then you no longer have an equality. Have I persuaded you? Yes.
You just cancel out the x squared at the beginning.
You can cancel whenever both numerator and denominator are in factored form. Now, the way to tell whether a polynomial is in factored form is to see if it's in termed form. See if it's in termed form, it's not factored form. Here we have three terms. Terms are separated by plus signs. Factors are separated by multiplication signs. So since it's not factored form, we can't cancel. If you do cancel, it changes the value of the expression. Okay, so that's all. Try number 2. Go ahead, factor and cancel. List your restrictions in the box. Have at it. What's going on here? We're back. I'm hoping that when you factored the numerator, 6x was your greatest common factor. And when it comes to the canceling phase of this process, the x's are gone. Switching to green, the 6 and the 3 are gone as long as you agree to replace that ratio with the number 2. So if you had 2 times quantity x plus 1 or 2x plus 2, you're in good shape. With the restriction, x cannot equal 0, otherwise we got division by 0. So let's reflect here on how things went for you on problem 2. Any questions on that? Owen?
Can you just factor it to 3x on the outside?
Yeah, I mean, you could factor out a 3x too. That would leave you a 2x plus 2 in parentheses. It's not the greatest common factor. That's a process called factoring out the almost greatest common factor. Not used every day, but today it's used by you. Further questions? All right. Now we're moving on to part 2, where it's the directions read, multiply and then simplify each rational expression, state any restriction on the variable. All right, so I guess we can just see what happens when we follow the directions. I mean, when I think of 15 times 6, I'm thinking 60 plus 30 is 90 x to the 4th y squared for the numerator. And I'll bet you the denominator simplifies to 40xy. So that's the first move, is to multiply. Multiply the numerators and the denominators together. The second move is divide, subtract. Because we're dividing exponential expressions, we're going to subtract the exponents. It's been my belief for years that 90 divided by 40 is 9/4. And then divide, subtract gives us x to the 4 minus 1, y to the 2 minus 1. So 9x cubed y over 4 should be the final answer. What is the list of restrictions? Please raise your hand if you have a restriction that you believe should be included in the purple box. Turn your paper non-purple. All right, let's go with Imani. What's a restriction you think we should include? Well, tell you what, look at the original problem. It's always based on the original problem. What values of either x or y would cause division by 0 in the original problem? Sorry? 0 for what letter of the alphabet? Yeah, you're right. If x is equal to 0, then this fraction will have division by 0. So x cannot equal 0. It's pretty good on that. What do you think over here, Lauren? What restriction should I add to this list of restrictions? Yeah, back in the original problem. We had a y in the denominator, so we cannot let y equal 0. Any questions on how to obtain the complete and correct list of restrictions for number 3? All right, so these restrictions seem like they're the most confusing part. And they seem to be revealed the best when both numerator and denominator are in factored form. So we have 3 expressions to factor. This is already factored form, 6 times x, but these are termed form. So let's factor these. Starting with 3x plus 15. What is the factored form of 3x plus 15? Please, Andrew.
3 for S2C is x plus 5.
Thank you. What is the factored form of x squared minus 9? Daniel.
X, would you start with
I would start out, well, I thought you said x. Yeah, the first factor does start out with x.
X minus 3? That's it.
Well, to factor x squared minus 9, there's more than just writing x minus 3. I'm sorry, what's that?
Would you do it 3 because you're dividing by 3?
Well, right now, we're not worried about canceling things yet. We're just in the factoring stage. So when you look at this difference of squares, x squared minus 9 is the difference of squares. It's kind of in the form a squared minus b squared. How would you factor a binomial?
Yeah, x minus 3. Yeah. No, x plus 3.
Yes, good. Thank you, Daniel. X squared minus 9 factors into x plus 3 times x minus 3. Now, these will not play into the restrictions. It's only the denominator factors that will play into the restrictions. Like, for example, when you factor a 2 out of 2x plus 6, and get this, then it's time to start listing restrictions. How many restrictions are there going to be in our list? Hold up a number of fingers that corresponds to the number of restrictions. I'll give you a hint. The answer will be either 0, 1, 2, 3, 4, or 5. So I've narrowed it down to only 6 numbers for you. Hold up the number of restrictions that we'll have. Please raise the number of fingers that corresponds to the number of restrictions. Focus. Okay, ready, set, display the number of restrictions. I see some people holding up 0. I see 1. I see 2. And, all right. Well, those of you who think there's at least one restriction, what would that restriction be? Help me with that, please. Sophia. Do you have a restriction on x based on what you see in the factored form? 0? So how should I write that down? X is not equal to 0. Yes, based on what we see here, x cannot equal 0. Those of you who think there are 2 restrictions, can you come up with another actual restriction on x that we can include in the box? Well, okay, Sophia, you've got another one. Go ahead. So it was 2. It was 2 restrictions. X cannot equal 0, neither can x equal -3. Any questions on those? Just a little bit clearer. It's nice they give us a restriction box. Otherwise, it'd be easy to forget about this part of the directions. You ever been in, or have you ever had a day like that where you end up doing part of the directions, but then it just doesn't dawn on you that there's more to the problem than what's in the first instruction? I know I have. I've had days like that. All right, well, see if you can simplify it and give your final simplified answer in a box. This is not the final answer. The final simplified answer is yet to come. Hello. Anything else canceling? 3 and the 6 cancel, provided we put a 2 down there. 3 goes into 6 twice. Now, some people are going to write the final answer as x plus 5 times x minus 3 over 4x. Others are going to write the final answer as x squared plus 2x minus 15 all over 4x. Multiply and then simplify. Yeah. So, we'll accept either one. I think technically this would be more simplified because to factor means to complicate or to expand it out. So technically this would be more simplified, but we'll accept either one of these 2 answers. Any follow-up questions on number 4? No questions? Okay. Please attempt the restriction box for number 5. If you want to put it in factor form, you can, but try to come up with a complete list of restrictions in problem 5. I'm going to tour the room, see what kind of stuff you come up with. Now, when you fill in the restriction box on problem 5, just check in with a fellow group member or 2, and then finish the problem. Welcome.
How do we know x restriction? -3, y -3. Couldn't switch right out to negative. Because oh, because they can't. So the restriction.
Okay, so now that we found on number 5 that from the factor form x cannot equal -5, x cannot equal 0, let's start canceling. And the x plus 5s are gone, but also a pair of x's cancel. After you cancel the x's here, instead of 2 factors of x in the denominator, we're down to only 1. And likewise, the 5s, there's a factor of 5 and 10. So 5 and 10 cancel, provided you're willing to add another factor or multiply by a factor of 2. So it appears that the final answer upstairs, we're down to x plus 4, downstairs is 4x. And the 4's do not cancel, neither do the x's cancel. So x plus 4 over 4x. Any questions on number 5? Yes, Lauren.
So the 10x squared, do you like get rid of the x?
Yeah, I think of that x squared as x times x. So this is like a pair of x factors in the denominator.
Yeah, but
So one of the x's cancels with one of the 2 x's here, leaving us with only the x. So I did kind of a creative move. I canceled the x with the exponent of 2, making it look like there's only 1 x down below.
yeah, but can't you like cancel both because it's for like the x squared plus 4x and not 3 by 0. Can't you cancel both?
No, not both can be canceled. Only one of these 2 x's cancels. Were you thinking that like with this x here?
Yeah.
Oh yeah, but that goes back to our discussion about canceling only when you have factors. X and 4 are now terms. So notice the numerator is in, quote, termed form, unquote. And so you cannot cancel this x term with that x factor. So termed forms don't cancel, factored forms do cancel. Further questions on number 5? go to the next page. Okay, now, as I was writing out the solutions, problems like this were the ones that I found to be the biggest stretch. Even for me, this was a stretch, because when you're listing the restrictions here, not only do we watch out for things like this denominator equaling 0, but hello, I can't let this numerator equal 0. Why is it that I cannot let x equal 0? I mean, if I have a goal of maintaining my reputation of being a mathematical law-abiding citizen, if I want people to think of me as someone who abides by mathematical laws, then why must I never let x equal 0 in this problem 6? I mean, come on, what's the big deal? Can't I let x equal 0? I mean, hey, it's in the numerator. Aren't I allowed to have numerators equal 0? Who can make the argument for me? Why can x not equal 0 on problem 6? Maybe we can let x equal 0 on problem 6. Can we? Owen, why not?
Because when you simplify it, you because of the last problems.
Well, those problems didn't have a division sign here. This problem has a new characteristic. It's this number divided by that number. Well, tell me this. Well, yeah, Sophia, go ahead.
When you divide fractions, you do change first, so it's an x on the bottom.
Yeah, once you replace division with multiplication by the reciprocal, x would end up in the denominator. And I guess I'm hoping that you'll be able to see that you can make the argument right here. Because if x does equal 0, then what would the value of this fraction be? When the numerator of a fraction is 0, Anna, what is the value of the whole fraction? When the numerator is equal to 0, then the fraction overall is equal to what? For example, take something like 0 divided by 19. What is 0 divided by 19?
0.
It's 0. So if x is equal to 0, then we would be dividing by 0. Okay, is that something?
That's crazy.
So that's why, just based on the original problem, have to be extra attentive when you see that division sign there. It's like, okay, I've got to watch out for things that would cause this fraction to have division by 0, but what if the fraction itself has a value of 0? So that's the basis on which x cannot equal 0 and y cannot equal 0. Now we can carry on with the ideas that Sophia was talking about, and that is to change division to multiplication by the reciprocal. Carry on, finish the problem from here, multiply and simplify. Multiply and simplify. Or simplify and multiply, because you know what, it's just painful for me to look at this and not cancel the 7 with the 21. Come on, I don't want to deal with big numbers unnecessarily. Cancel the 7 with the 21. Furthermore, cancel the 4 and the 8, yielding a much more manageable number 2. So cancel and then multiply. Upstairs is 2xy. Downstairs we've got 3x cubed y cubed. There's more canceling to do though. A pair of x's will cancel, a pair of y's will cancel. What do you anticipate the final answer will be for problem 6. Help me out with this one, please. Jonathan, final answer. After, there's more canceling to do, but when the cancellations are completed, what will remain?
Do not know.
Well, let's talk then about, do you want to use the divide subtract rule, or do you want to write out x cubed as x times x times x so you can actually see the cancellations?
Oh, you can just subtract this.
Okay,
So it'd
then the final answer is what?
2 over x, 3x squared, y squared.
Nice. You got it, Jonathan. Final answer with restrictions. Any questions on problem 6? Andrew?
What? Why wouldn't you use the reciprocal of 7x over 4y? So would you flip both the equations or just one?
Well, here's the idea. If you have, let's go back to arithmetic. If you have 3/4 divided by 7/8, division by a fraction is the same thing as multiplication by the reciprocal. So you flip the second fraction, not the first fraction. Now, if you find yourself not believing this, but it was just 24 over 28, reduces to 4 goes in there 6. 4 goes into 28 7 times. So if we were to check this on the calculator, we took 3/4 divided by 7/8, convert frac, should come out to 6/7. So, but again, we're just addressing the question of, why don't we flip both fractions, why just one? So when this comes up, we check it, oh, it's almost up. Okay. 3/4 divided by 7/8. Convert frac. So sometimes, when I am thinking, wait, am I thinking about this correctly? I'll just do a quick numeric example to kind of help me get back in touch with reality. 3/4 divided by 7/8. So 3/4 divided by 7/8. Math 1 is convert frac. It is 6/7, thus confirming my theory that you flip only the second fraction. Further questions on number 6? All right, now there's something new on number 7. Number 7 looks like 18 will never equal 0, so we don't have to worry about this numerator being equal to 0, but this denominator could equal 0. We've got to watch out for that. Also, this denominator could equal 0. So if you're wondering, what would cause x minus y to equal 0? Because we know that x minus y cannot be equal to 0. We're committed to not dividing by 0. So instead of a number, we find out that x cannot equal y. It's like x and y can really be anything, as long as they're not equal to each other. It's okay for x to equal 0, as long as y does not equal 0 at the same time. So here's a new restriction. It's a restriction where both sides of the does not equal to sign has letters. X cannot equal y. Also, this other denominator, 5x minus 5y, is not allowed to be equal to 0. Therefore, 5x cannot equal 5y, but divided by 5 gives us the same thing. So we don't have to write it twice. We're not obligated to write the restriction twice when they're identical. So we're good to go. We've got the restrictions. Arguably the hardest part of this stuff is the restrictions. So now that we have that done, let's factor, flip, factor, and cancel. Flip and factor can happen on the same step if you're so inclined. It wouldn't offend me if you combine your flipping with your factoring. Let me demonstrate. I can factor as I flip, changing the second fraction to its reciprocal. Factoring and flipping has happened in one fell swoop. Any questions on how to dovetail your factoring with your flipping? Okay. See if you can beat me to it, finish the problem before I do, as if. Did you decide to cancel the 6 with the 18, reducing it to 1/3? So, if your final answer is 5/3 times x plus y, we're in good shape. If you did 5x plus 5y all over 3, that also is acceptable, either one. Or 5 times quantity x plus y all over 3. Any questions on problem 7? Problem 7. All right. The factored form of the first denominator is x plus 1 times x plus 1. What is the factored form of, well, you know, let's just relax here a little bit, Mr. Royce. Before we actually go to flipping, let's just get the restrictions down. And, which means I'm not going to combine my factoring with my flipping. I'm simply going to factor and then list restrictions. Once again, let's go to a display of fingers, either 0, 1, 2, 3, 4, 5, or 9. It's one of those answers. How many restrictions are there? Just as a favor to you, I'm going to make a multiple choice. The answer is either 0 restrictions, 1, 2, 3, 4, 5, or 9. Okay? So go ahead and think about that. Pick one of those. Okay? And now display the number of restrictions on your fingers. Okay. Go ahead and display the number of restrictions. How many restrictions are there? In problem 8. So I'll give you an additional hint. It's not 9. Okay? It's not 9 restrictions. Let's try it again. Jay, go ahead and display the number of restrictions with your fingers. We've narrowed it down to either 0, 1, 2, 3, 4, or 5. 4. Thomas? You know what? There's a lot of different answers. Just stop what you're doing, pencils down. We need to, this is the hardest part of the lesson. You have to really wrestle with restrictions. So now I'd like you to talk in your groups. See if you can come to an agreement as to how many restrictions are there in this problem. Go ahead and talk about it.
No, it's 3, because this box is bigger than this box.
Because it can't be 0.
-1 and 1.
But over here, 3.
It can't be equal.
That would be 0.
Can't be
That's
zero.
-1.
Can't be -1.
The left side will be gone to 0.
And then it can't be positive 1.
Oh, it can't be. Wait, why can't it be?
I haven't gotten a lot of
It
these.
can, because there's a -1 on the bottom.
So we
There's
flip
no
it to
negative
find
on
out.
top.
Yeah, x minus 1. The denominator.
Okay,
Before you-
let's try this again. How many restrictions will there be in problem 8? Hold up a number of fingers, ready, set, display. Okay, now it looks like we're down to between 2 and 3. Some of you have 2. I'm seeing a lot. You got 3, you got 2, or is that 3? Are you doing 2 or 3? Are you using your thumb as one of your fingers? Oh, you're doing, okay. Here we go. I'm telling you for sure that there's a restriction on -1, because over here you cannot let x equal -1. That's one of the restrictions. Can we get 2 more? Because a lot of you seem to think there's 3 restrictions. Well, wait a second. We cannot let x equal +1. That's a second restriction. But for those of you who think there's a third restriction, what is that third restriction that you think exists on this problem? Anyone? And Bethany,
X cannot equal 0.
x cannot equal 0, cannot equal. Why can x not equal 0? I don't see any just plain x's down here in the
Well,
denominator.
At the top, if you put 3x and you put that as a 0, it would have been 0 over that and would have made the thing a 0.
Make this whole fraction 0, and then you'd be dividing by 0. You're right, you cannot, there are 3 restrictions. Thank you, Bethany, it's well done, seriously. All right, any questions on how to locate all 3 restrictions? For a while there, I was thinking it might be 9, but no, I've seen the error of my way. It's really only 3 restrictions. All right, so we gotta finish the problem up. Go ahead and finish up number 8, try to get a completely simplified answer, and then you can double check your work with my work. You know, just for kicks, I'm gonna write that x squared as xx. X. What is this? Oh, so my work arrived at this. Now, if you write your final answer as x squared minus x over 3x plus 3, fine with me. We're pretty easygoing here. Well, except either one. Any questions on this? By the way, homework 9.4a. It's an online submission. And one, getting ready to transition into our review activities and to give you back some of the other homeworks that you've turned in. Why don't you give this a go? Try to do these 9 problems. Actually, it's probably 10 problems. 2, 4, 6. There's only 9. Okay, try these, and then we'll do some review activities.